Hello and welcome to 15.3 Tangents and Circumscribed Angles. It's on page 15 of your packet, so let's go there right now. So, they use this word tangents and then circumscribed angles. So we're going to talk about that. First of all, what is a tangent line? What is a point of tangency? Let's go with the basics. So, you'll see that a tangent line is essentially a line that touches the circle. And the point of tangency is essentially where that line touches the circle. There's no real place on your packet for this, but please make a space, because essentially these are the two concepts or the two vocabulary words that we're going to be focusing mainly in this lesson today. Point of tangency, where it touches, tangent line, the line that touches the circle. All right, in your credit, you see there, oh my gosh, there's a little circle and a big circle and a bunch of lines everywhere. Take a moment right now and go ahead and figure out where or what are some of the lines that you see that touch a circle. I'll help you out. That's a line that touches a circle. See if you can highlight a couple more on your page. And we could say, hey, line BC, or in this case, CK, could be a line of tangency. There's a bunch, by the way. There's one right there. By the way, why wouldn't I highlight this line right here, FH? Because it doesn't touch the circle. It goes through it, right? So that's another line you could kind of use. You could say CD, or DF, or EF, or pretty much any letter variation of letters that you want to use. All right, and there's a bunch of points of tangency, so I'll go ahead and make those go away. Oh, that was pretty. Let's watch that again. Anyways, moving on, points of tangency. That would be essentially where our circle touches the line. In this case, it touches right there. Go ahead and take a moment and see if you can find some other points where the line touches, not goes through, touches the circle. And if you found a couple, one of them is B. Yes. Another one is D. Another one's K. And another one is E? E. All right, are there any more? Nope, that's it. That comma is misleading. There are no more. All right, let's move on. So tangent radius theorem. So here I have a tangent and it touches a radius. So essentially PT, which is our radius. So I'm going to write that there and I'm going to label it radius. Nope. If I can label it radius. Go ahead and do so now if you haven't already done so. Label radius. Because it is the radius. All right. And notice there's this upside down T. It's a symbol. It means that essentially this radius crosses this line at a 90-degree angle. What line? That line! SR. Okay. And that is our tangent. It crosses at a 90-degree angle. Pause if I'm going too fast because I'm going to move on in 3, 2, 1. Here we go! So here it says both lines in this figure, are tangent to the circle. And they cross that diameter, AB. What can you conclude about the tangent lines? Well, I know that they're tangents. There's one line, there's another. That means essentially they cross at a 90-degree angle here and a 90-degree angle there. I know this was a while ago, but first semester we learned about angles, that essentially if some stuff is true about angles within two lines being cut by another line, we know they're parallel. So 90 and 90, those are the same. Would you say that they are same side interior, meaning they're on the same side of this line and inside the parallel lines? Are they alternate interior, meaning they're inside the lines, but they're on different sides of the line? And by that line, I mean the diameter. Or are they corresponding angles, meaning they're in the same place? They are. Which of these postulates can prove that these lines are parallel? Hint, the lines right here, these tangent lines, are parallel. And that would be the same side interior angles add up to 180 because 90 plus 90 is 180. So go ahead and fill out your sentence starters. The lines are blank because the angles on the same side add up to blank. So the lines are parallel because they add up to 180. All right, moving on. Another theorem, circumscribed angle. So highlight angle L and angle O and write them here. Essentially, if I add these two angles together, they are equal to 180. And the reason for this is because I know that that radius touches that line and it crosses at 90 degrees. And this one too. And what is 90 plus 90? 180. So there's that pattern again. It's very similar to 15.2, which if you haven't done that yet, watch that video. All right, let's find some missing pieces, guys. Let's go ahead and highlight. Here's my angle, 117, which I know, and a question mark, which I don't know. What's a letter we could use for something we don't know? A letter. And you can pick whatever letter you want. I'm going to use Y. Don't know why, just I am. So let's go ahead and solve this out. What's the opposite of adding? Subtracting. So that means Y equals, by the way, that'll cancel out. Y equals, what's 180 take away 117? Calculate it out. You can do this. Try it out. Trusting that you did this, 63 degrees. All right. So this one does give us a variable, x, 45. Let's go ahead and set up yet another equation. Set it up. Solve it out. And hopefully you solve this out. That would be 45 plus x. The opposite of adding is subtracting. All right. And if you subtract 45 from both sides, what would you get? 135. All right. Let's keep it on going. Oh, that was the fastest lesson in all of history. All right. 15.3. That was a very short lesson. Essentially, we have angle Q and 42. So we'll have 42 plus angle Q equals 180. Go ahead and solve that out. And if you solve that out, that would be 138. All right. Make sure you're doing the homework. If you need support on any one of these, I do provide some support in the video, so feel free. For number 4, they do give us a picture. I would say, hey, just in case you remember, that's a triangle. I know that that radius and that tangent cross at 90 degrees. And I know this is from first semester, but all these angle measures, 59, 90, and what I don't know, all add up to 180. So let's go ahead and plug that in. By the way, if you want to pick a letter for what we don't know, in this case, R, you can use R if you want. You can use whatever you like. But let's go ahead and solve that out. And see if you can solve for angle R. I'm not going to do that all the way, but go ahead and try that out. For number 8, they tell me that QS is 5, which is our radius. That means that this must also be 5, by the way. Oh, thank you, computer, for highlighting that out. We also know that from the information they gave us, that because this radius and this tangent touch, it crosses at a 90-degree angle. So that's kind of nice to know. They tell us that RT is 12, which is already labeled for us, which is nice. And we're trying to figure out what this would be, right? Which we don't know. Because I don't know what QT is. I know what QS is. I don't know what QT is. If you'd like, pick a letter. If you're not a fan of X, go ahead and pick a different one. I know this is not algebra class, but we're using Pythagorean theorem. If you're wondering, what is this? So when you were in algebra, we talked about triangles a little bit. And actually, this is not the first time we've seen this. For a right triangle, this works only for a right triangle. The side opposite 90 degrees is called our hypotenuse. And the legs, or the other sides of our triangle, are called our legs. So in this case, I have a triangle, 5, 12. Ooh, I know the legs! 5 and 12. That must mean the hypotenuse is x, because it's the side opposite 90 degrees. So let's plug some stuff in. All right. By the way, if you put 12 here and then 5 there, it doesn't matter. But go ahead and work that out. What is 5 times 5? What is 12 times 12? X times x is just, oh, I help you out. So work that out. See what you get. Pause and unpause. That would be 25, 144, and x squared. Go ahead and add that together. What is 25 plus 144? I wonder. Hopefully you paused and you worked that out. That would be 169. Now if you're wondering, how do I solve from here? We're going to square root both sides. There we go. We're square rooting. That's x equals, pause, square root this out, 13. Number 13. They give me this picture and they tell me to find angle P. So again, I'm going to kind of do this, 90 and 90, because they are radiuses that touch the line. But I want to find out what angle P is /x. So what I'm going to do, set up an equation where I have x plus 3x. So solve this out. Work this out. If you have questions on how to do this, please come into the center. We will help you. But like I said, if you have any questions at all on any of the problems here, please come into the center. All right, we will be more than happy to help you. Just come in and ask. All right, with that being said, we'll see you back here on the next video.